Good morning. I got some questions from Melissa and Maya, and I'm going to do them for you. This is number 11. It's on page 517. I did some work of it, and I will do the tricky part here, but I did the systematic part by myself to save time. So they give us the equation of two planes, and they said that we need to find the length of the. So it says determine the parametric equation of the line of intersection. So I followed the steps that we learned yesterday. We get rid of one of the variables, so I decided to get rid of the x. So I multiplied this equation by -2 and I added. I get this and I simplified to 1 minus z equal 1. Then I set z to t. Then I solved for y, so y will equal 1 plus t. Then I substituted in this equation for z by t and for z by t and for y by 1 plus t, and I solved for x. So I get the parametric equation of the line of intersection of these two planes. Now it says this is the hard part B. It says if L meets the xy plane at point A. So this is the xy plane, this is y, this is x, this is z. So this line will meet the xy plane at point A, and it will cut this line, will cut the z-axis at point B. We need to find the length of this line. Okay, so in order to find the length of this line, I need to find this point and this point. This point lies on the xy plane. So what is the z value of this point? It has to be 0. So I have, let's say, a, b, and 0. I need to find a and b. So when z is 0, z equals 0, t equals 0 because z equals t. So y will equal 1 plus 0, which is 1. And x will be another 1. Okay, so the coordinates of this point is 1, 1, and 0. Just z is 0 because it lies on the xy plane. T is 0. I found x and y of the point. Now I know the coordinates of this point. For this one, I have here 0, 0, and let's say k. Because any point on the z-axis has xy equals 0, 0. So when I put 0 for x, y, 0 for x or 0 for y, 1 plus t, so t will equal -1. Same thing if you do that in here. Y equal 1 plus t, so t equals -1. If t equals -1, that means z equals -1. Okay, that means this point will cut, this line will hit the z-axis at -1. So now I know the coordinates of these 2 points. I can find the distance. It will equal the square root of 1 minus 1 squared plus 1 minus 1 squared. 0 minus -1 is 1, so squared, and this is square root of 3, which is 1.73. This is the distance between these 2 points. Okay, so this is question 11. Question 10. Question 10 says, for the plane, we have an equation of a plane 2x minus y plus 2z equals 0, and another one is 2x plus y plus 6z equal 4. Show that the line of intersection of these two planes lies on the plane with the equation 5x plus 3y plus 16z minus 11 equals 0. So the first thing we need to do is to find the equation of the line of intersection. So to do that I will find first the equation of the line of intersection. So I can get rid of any of the variables. I can see that if I subtract, I'll get rid of the x. If I add, I get rid of the y. So I will add and get rid of the y. So 2x plus 8z equal 4. Now we let either x or y or z equal t. So let z set z equal t. In this case, 2x plus 8t equals 4. So x will equal 2 minus 4t. Okay, 2 minus, oh no, when I add I get 4x, sorry. So this will be 4. So when I said it, I sent it to the other side, it will be 1 minus 2t. So x equals 1 minus 2t. Okay, I added these two equations. I let z equal t. I solved. I get x. Now I need to find y. I just gonna substitute in the equation. So 2 minus 4. I will substitute in the first equation. 2 minus 4t minus y plus 2t equals 0. I take z and put t. I solved for y, so y equals 2 minus 2t. So this is the parametric equation of this line of intersection. So if I want to write it in vector form, it will be 1, 2, and 0 plus t times the numbers in front of this, negative 2, negative 2, and 1. This is the vector equation of the line of intersection. Now we need to show that this line lies on this plane. If this line lies on this plane, two things must be true. The first thing is the direction vector of this line makes a 90-degree with the normal vector of the plane. So I need to see if the dot product of m dot n equals 0 or no. So m is negative 2, negative 2, and 1. Dot the n, which is 5, 3, 16, and if you do that, you will get negative 10, negative 6, plus 16, and that is 0. So yes, the first thing is true. So now these either the line of intersection is parallel to the plane or coincident in the plane. How we differentiate? We get this point and substitute it in the equation of the plane. If the point lies on the plane, it is this case. If not, it is that case. So now we are going to substitute with 1, 2, 0 for x, y, and z. So 5 times 1 plus 3 times 2 plus 16 times 0 minus 11, is that equal 5 plus 6 minus 11, which is 0. So yes, the point lies on the line. So the point on the line lies on the plane. So yes, it is coincident. The line lies on the plane. Okay. So I I will, not coincident, it is the line lies on the plane. Yes. Line is on the plane. Okay, so what I did, I found the line of intersection, I found the direction vector dotted with the normal vector. Yes, it gave me 0, so I have these two cases to differentiate which case is it parallel or lies on the plane. I get the point on the line and substitute it in the equation of the plane and see if the point lies on the plane. Yes, it does, so the whole line has to lie on the plane. Okay, this is number 10. Now I'm going to do number 9. If Melissa, you asked me about number 7b, d as well. If you understand number 9, it is much harder than number 6. So, and the same, the plane has two only y and z. So, pi 1, 2x minus y plus z equals 0, and pi 2, this is number 9. Pi 2 is y plus 4z equals 0. And determine the vector equation of the line that passes and is parallel to this. So, what is the idea of this? These are two planes that are intersecting. So, these are two planes intersecting in a line, this line. And we have a point here, A. The coordinates of this point is negative 2, 3, and 6. And we need to find the equation of the line that passes through this point and at the same time parallel to the line of intersection of the two planes. So we know that parallel line has the same direction vector. So if I get the equation of this line and I can use, I will know the direction vector of this line as well, and I can find the equation of this line because I know direction vector and the point. So the first thing, I need to find the equation of this line so I can get the direction vector. What is, Melissa asked me yesterday, if we have two variables only, is this a line? No, it is a plane, but the normal vector to this plane is 0, 1, and 4. So the normal vector of this plane, the vector that makes 90 degrees of this plane, lies on the YZ plane. So Y is 1 and Z is 4, and this is the normal vector. So the plane will be something makes 90 degrees with this. You understand? This is a plane, not a line, but the x component of its normal vector is 0. So that's why it looks like this. Okay? Now, so we are going to find the line of intersection. We are lucky we don't have, we have only 2 here. We don't need to do the first step, the elimination. There is one eliminated already. So I will let z equal t. I can let y equal t, no problem. So y will equal negative 4t. Okay, now I substitute in the first equation. So 2x plus 4t, because y is negative 4t, plus t equals 0. So 2x equal negative 5t. So x equal negative 5 over 2t. Now I have the equation of the line. I have the parametric equation of the line. I can get the direction vector of this. Those are the numbers in front of. Is it right? I wrote the question correct. Yeah, I can find the direction vector. So m will equal. Okay, I will continue in the next video.